Welcome back. Today we're going to talk about 2.7, solving equations in one variable. Some of this is going to be a review, some of it might be just shaking off some of that rust, some of it might be brand new to you, so here we go. This directions simply say solve. And so when we're given an equation like this, there's a bunch of different ways to attack this. But one of the things that I want to try to get you to do is to eliminate fractions. And we're going to do that multiplying by the LCD, or at least a common denominator, but in this case we're going to find the LCD. So if I look at my least common denominator, I'm going to check out all of my denominators. So I've got 1 and x and 1, because those denominators under x and 4 are 1. And so my LCD is going to be equal to x. So what I'm going to do is I'm going to multiply both sides of this equation by x. And so I'm going to have x times x plus 3 over x equals 4 times x. When I distribute this in, I've got x squared, and then multiplying by an x is going to give me just 3, and then that's going to be equal to 4x. Well, when I do that, notice what I've got here. I've got a quadratic. I've got an x squared, I've got an x, and I've got a 3, so I'm going to do some rearranging. Subtract 4x from both sides. So I'll have x squared minus 4x plus 3 equals 0. Well, this is something that we've done quite a bit, and so if I've got it equal to 0, I can factor, I can use quadratic formula, any of those options will work. So I am going to factor this because I see that I've got a positive 3, so I need two things that are going to multiply to positive 3 and add to negative 4, so I'm going to factor this as x minus 3 and x minus 1, because the negative 3, negative 1 are going to multiply to 1 or multiply to 3 and add to negative 4. Well, that leaves my solutions as x minus 3 equals 0 and x minus 1 equals 0. So x is equal to 3 or x is equal to 1. Two solutions. Well, for this section, what we're going to be exploring is the possibility that I find a solution that's not actually a solution. And so I want to check up here. And how do I check to see if a solution is actually a solution? Well, first of all, I could graph it and see if it's on the graph. Secondly, I could evaluate. And I'm actually going to do that for this one because this one's fairly straightforward. And so I'm going to plug in 3 and 1 into my original equation. So x equals 3 is going to give me 3 squared. Evaluate into the original. I'll have 3 plus 3 over 3 equals 4. And actually I'm testing to see if that's true, because if it's true, then it is a solution. So I plug my x equals 3 back into my original equation. Well, 3 plus 1 is in fact equal to 4, and so 3 is a solution. Let's try the next one. X equals 1. So I'd have 1 plus 3 over 1, which is equal to 4. So 1 plus 3 equals 4. So yes, that works, and this is also a solution. So my solutions would be x equals 3 and also x equals 1. Okay, so for that one I had two solutions that worked. Let's check out the next one. I'm still going to find the LCD for this one. Find LCD. In this case, I've got a 1 as a denominator here and x minus 4, and no denominator there. So my LCD is going to be x minus 4. So what I'm going to do is I'm going to take this whole thing, multiply both sides by x minus 4. Here's what it gives me. X minus 4 times x plus 1 over x minus 4 equals 0 times x minus 4. That's kind of convenient. And so I'm going to be left with x times x minus 4 plus, and when I multiply this one, my denominators are going to cancel out, so I'll have x minus 4 times 1 over x minus 4 equals 0. And so these cancel, so this is plus 1 here. This one's going to give me x squared minus 4x plus 1 equals 0. So now I've got some options. I can factor it. I can use quadratic formula. I could complete the square. I could graph, those sorts of things. So let's use quadratic formula for this one because I don't see anything that obviously multiplies to 1 and adds to -4. And so let's use quadratic formula. So x is equal to -b, so -4, so 4 plus or minus the square root of -4 squared minus 4 times 1 times 1, 4ac all over 2 times 1, so 2. When I simplify this, I've got 4 plus or minus the square root of, this would be 16 minus 4, so the square root of 12, and this is all over 2. If I continue up here, I've got 4 plus or minus the square root of 4 times the square root of 3 over 2. So 4 plus or minus 2 root 3 over 2. And my 4 and my 2 cancel, so that gives me 2 plus or minus, and then these cancel, so plus or minus square root of 3. So I've got two solutions here. So x is equal to 2 plus or minus the square root of 3. Up here, I evaluated. On this one, let's go to the graph and see. If I plug these into my calculator, okay, so I find 2 square root of 3, or 2 plus square root of 3 and 2 minus square root of 3, I get that these are about equal to 0.268 and 3.732. Okay, so those are the decimal approximations of 2 plus square root of 3, 2 minus square root of 3. So when I look at my graph, what am I looking for? Well, I'm looking to see if those are actually where it equals 0. So where the function equals 0. So those would also be known as my x-intercepts. So here's my function, x plus 1 over x minus 4. And I'm trying to figure out where they equal 0. Well, if I hover over my graph here and you do a second trace, find those zeros, I have 0.268 and also 3.732. And so when I go back to my evaluations here, this is a solution, and also this is a solution. And so what I just did was, instead of trying to plug it all into this original formula, which I could do that. But what I found was I could use the graph to find zeros. And we could check. So, you know, you could have a direction that says use your calculator to find, or on a no calculator section, I could have you evaluate it. But that's another way to check to see if you're right. All right, let's check out this beast here. This one here, we've actually got 3 denominators. And so if I'm going to find the LCD, I actually want to try to break this one down to see if it's has any common factors with my other 2. And what I find is when I factor this, I need 2 things that multiply to 3 and add to -4. Well, check this out. Conveniently, but not coincidentally, it becomes x minus 3 times x minus 1. We'll check out what just happened right there. I factor this to see if there's anything in common with these other ones. Well, look, it's actually a combination of the other 2. So what does that mean? Well, my LCD is then going to be x minus 1 times x minus 3. So it's the combination of both of the singles plus the one that forms the quadratic. So when I multiply this whole thing by x minus 3 times x minus 1, here's what I get. X minus 3 times x minus 1 times 2x over x minus 1 plus 1 over x minus 3 equals 2 over, and I can now write this in its factored form just to make it very, very clear. And I'm multiplying that by x minus 3 times x minus 1. Okay, so when I do this, check out what happens. When I distribute this to here, the x minus 1 cancels. Okay, so these are gone. I'm not going to cross them out because I have to do that multiplication again. I don't want it to be confusing. But what I'm left with is 2x times x minus 3. When I distribute it here, my x minus 3 cancels, but I'm left with my x minus 1. So I've got plus 1 times x minus 1. All right, so that's how it works out when I've got those two separate fractions. Only half of my LCD actually cancels in there. On this side, it's cool because both cancel, and so I'm left with it's equal to 2. Check out how much easier this is now. In my original, I had this quadratic, I had an x minus 1, I had an x minus 3, but now I'm left with just factors that I feel comfortable with. So when I distribute this in, I get 2x squared minus 6x plus x minus 1 equals 2. Quadratic, 2x squared minus 5x, and if I subtract 2 from both sides, I get minus 3 equals 0. Well, look at this now. This is what I'm solving, a quadratic. I've got a couple of options. I can factor it, I can find my, use my quadratic formula. I'm going to factor it, and so on top goes a times c, on the bottom goes b, minus 5, 2, and 2. What multiplies to negative 6 and adds to negative 5? Well, I'm going to have 1 and negative 6. And so this would become 1 minus 3. This would be 2 over 1. So I've got 2x plus 1 times x minus 3 equals 0. So that leaves me with 2x minus 1 equals 0 and x minus 3 equals 0. So x is either equal to 3 or I would have, nope, this should be plus 1. So I should have 2x equals negative 1. So x is equal to negative 1 half. So I've got two things to test. I could go to the graph, but let's just take a look here. If I'm going to evaluate this, I'll use blue to evaluate. All right, so first I'm going to look at x equals 3 because it's a whole number and I'm feeling a little bit more confident about that one. If I was going to plug x equals 3 into the original, just theorize with me here for a minute, I'd get 6 over 2. That's okay. But then when I plug it in here, look what happens. 1 over 3 minus 3. Well, what does that mean? Well, that means I'd have 0 on the bottom, which means it's undefined. So actually, this is not a solution because 1 over 3 minus 3 is undefined. Okay, 1 over 3 minus 3 is undefined. That's from my original function. So I'd have 0 on the bottom, which makes it undefined. And so I already know that this is not a solution. So let's test the other one. There's no obvious, bottom parts that make it so it's undefined. And so let's just evaluate. So I've got 2 times minus 1 half over negative 1 half minus 1 plus 1 over negative 1 half minus 3, oh boy, equals 2 over minus 1 half squared minus 4 times minus 1 half plus 3. All right, so just take it in steps. Here we go. So on top I'd have negative 1. On the bottom I would have 1 half, negative 1 half minus 1 would be negative 3 halves. And so I'd have plus 1 over, now this would be negative 1 half minus, and this would be 6 over 2, so this would be minus 7 over 2, so this is just common denominators. Over here I'd have 2 over, and this would be 1/4, and this would be minus, and so 4 times negative 1 half would be minus a negative 2 plus 3. So I've got dividing by fractions is the same as multiplying by its reciprocal. So here I'd have 2/3. And then multiplying by the reciprocal again, I'd have minus 2/7. So I'm just taking this minus 7 halves and saying it's 1 times negative 2/7 is equal to 2 over, and this is 1/4 plus 2 plus 3, so plus 5. So this would be equal to 5 1/4. So 5 is actually equal to 20 over 4. So this would be equal to 2 over 20 over 4, which would be equal to 8/20. But I've got to have that extra 1/4 in there, so this would actually be 21/4. And so this would be 8 over 21. Okay, and if I'm looking on this side, conveniently I have 3 and 7 as my denominators, which are going to be 21sts. So if I convert these to 21st, this would be 7 over 7. So this would be 14 over 21. And this one would be 3 over 3. 14 over 21 minus 6 over 21. And so is 14 21st minus 6 21st, is that actually equal to 8 21st? Well, this would be 8 over 21 is equal to 8 over 21. Okay, so I think the most confusing part of this one is obviously this part right here. And so if I convert that, this bottom part would actually be equal to 2 over, and then you've got 21 over 4. And so getting that common denominator is a key. I've got that 8 21st is equal to 8 21st. Well, what does that mean? Well, that means that x equals -1/2 is a solution. And what does that mean for me? It means I came up with two possibilities. I eliminated one of them because I plugged it back in and I found that it was undefined. And one of them worked. Well, what would be the easier way to do this if I didn't have, if I had access to my calculator and I didn't want to do all this, common denominator stuff? I could check my graph. So if my graph says that -1/2 is a solution, it would work. Okay, so that's the way that we can do it. So we find our solutions, check our graph, check our math to see are any of them eliminated, and then whatever's left and works is the solution of that equation. All right, I'm gonna let you try this one. It's got a little trick at the end there. So you've got x plus 2, and then x squared plus 2x. So you're probably gonna want to factor this one, and you're gonna want to multiply by that least common denominator to see what your solutions are. Okay, so try those, come back, we'll talk about it tomorrow, or try this one, we'll come back and talk about it tomorrow, and we'll see you next time.